get from the graph. So there are three types of graphs. Just quickly again. The first graph is a displacement versus time graph. The second graph is a velocity versus time graph. And the third one is an acceleration versus time graph. Yes. So not just in kinematics, in everything in science, there's always two things that you can possibly use. And that's the area or the gradient. And if you forget, please don't think it's only for motion. Always go and think, if they give you a graph, ask yourself, does the area give me something? Does the gradient give me something? And you're always going to do that. We will post the picture for all of you that we took of this. So you don't have to worry about writing it down. Okay, so if for the first one, the area you always know is going to be side times side. So it's x times y. If you're thinking about a graph that this is y and this is x, so it's x times y. So this is going to be, remember the unit for this is meters, seconds. I'm going to go fast because we've done this before. This is meters per second, and this is seconds. This is meters per second squared, and this is seconds. Stop me from going too fast, but I'm assuming you've all done this. So if we go and say area, it's always side times side, length times breadth, half base times height, but it's always side times side. So it's meters times by seconds. That's the area. The gradient is always y over x. So that's going to be meters divided by seconds. So you can see for yourself now that this gives me nothing. I can do nothing with meters times by second, but I can do something with meters per second. That is going to give me the velocity or the speed if it's in a straight line. Then, so you don't have to go, you can go and learn it, but if you forget in an exam stress, I always say, makes your brain go all weird. Here, area again is x times y, gradient is y divided by x, so here it's going to be meters per second already, and now we're going to say let's times that by seconds, which means it's a plus 1 and minus 1 cancel each other, we end up with meters. For this one, it's meters per second again, divided by seconds. Oh, that's not a minus plus 1 at the bottom of the line, but it goes up and it becomes meters per second squared. So you can see that this time there are two things. We do have something that we measure in meters. What is that? Yes, so this is going to be displacement or distance. Do we have something that we measure in meters per second squared? Acceleration. So yes, and that is why you will see this graph is the one that is most often asked, because we can use it to get the displacement by getting the area, or we can use it to get the acceleration by getting the gradient. Then for the last one, for the area here, it's again x times y, and here it's again y divided by x, the gradient. Now this time for the area, it's meters per second squared times by seconds. That's a plus 1. So the plus 1 cancels one of those and we end up with meters per second. I'm assuming your maths is amazing because you're taking science. And this is meters per second squared over seconds, which becomes meters per second to the minus 3. Is there anything that we measure in meters per second to the minus 3? No, but yes, we do have meters per second, and again, that is going to give us the velocity. Okay, so if you forget, always just go and check that. So when you get a graph, like the one we just have here, the first thing you're going to do is say, what graph do I have? What can I use? So that's always your first step. So if we look at this graph, what graph do I have? Velocity time graph. As soon as you told yourself that it's a velocity time graph, before you even look at the questions, guys, because that is going to confuse you, just immediately say to yourself what you can use. write it down because you're going to use it at some point, so it's never a waste of time. Gradient and area. If it's a velocity time graph, what does the gradient give me?
It gives you.
It is a velocity time graph. What is the gradient give me?
It gives you speed or velocity.
Guys, I'm going to say it again. Okay, let's go back here. Guys, it's this graph. It's a velocity time graph. The gradient is meters per second divided by seconds. Can you see why? In an exam, you think you've memorized it. And it's happened to most of you here, where you now forgot already. And I just said it 5 seconds ago. Gradient is meters per second over second. So it's meters per second squared. So it's the acceleration. Please, that is the most important thing. Gradient gives us the acceleration. What does the area give me? That gives me the displacement. So can you see why it's important to go and write that down before you even start with the question? Because if you jump into the question, you get confused. Don't let that, and in an exam, it's worse. Then the next thing that you do before you start answering the question is there's a velocity time graph. So here all the velocities are positive. So write for yourself here. Positive velocities are here, and the question told us that it's starting at 8 meters per second north. So anything above the line would be north. So what will anything below the line? This is what, when I say anything, I mean velocities, because it's a velocity graph. So velocities above the graph is north, velocities below the graph is their negative, and it will be south. Once you've done those two things quick, gradient, area, north and south, then you start looking at the questions. Now we're going to say, if the gradient of the graph between t equals 0 and t equals 5 is minus 4, 0,4, calculate the value of v. So they've changed it around a bit. But don't get confused by it. Just trust your training, guys, always. Because they're telling you what the gradient is. So they're telling you the gradient is equal to minus 0,4. You know the gradient is change in y over change in x, right? Is equal to 0,4. And they're asking you what the velocity is there. So now we're going to say, okay, if it's for the first 5 seconds, you are allowed in science to use a highlighter or colored pencils. They're looking for that little bit there. So for this question, we're looking for that little bit there. So we're going to say, yeah?
Do you have to drop the minus?
No, you definitely must not. If they give it to you as a minus, you need to keep a minus. Yes. Sorry, that was a mistake. So we're going to say final minus initial. So it's always for a change, it's final minus initial. So it's V naught is the one that they're asking us, or that V that they're asking us for. I'm just calling it V naught because it looks like a naught there. Minus, that's our value, minus 8. Always for the last one minus the first one. Then the times is 5 minus 0. And this is equal to minus 0,4. Now you already have all the science marks. The science marks are for realizing that the gradient is 0,4, that the gradient is change in y. They didn't actually have to tell you that it is the gradient. What would we do actually in next week's test? Well, we tell you that it's the gradient that is minus 0,4. Yes, we would say the acceleration is 0,4, that you need to realize that the gradient is equal to the acceleration. That's what we will do in a test. Now the rest is algebra. All you have to do is say, fine, I know these values now. So we can do the algebra. Remember, that goes first. or you can just do it on your calculator. We don't give you any other marks. Oh, I was talking about the marks. 1 mark for that, 1 mark for that. 1 mark for substitution. And then you only get 1 mark for the answer. So the maths from here to the answer that says V equals, it's only worth 1 mark. So your calculator job gets 1 mark only. Yes.
So ma'am, I just wanted to ask, isn't changing y over x and gradient the same thing?
Yes.
So ma'am, writing that charge gives you 2 marks.
No.
Like ma'am, gradient.
If there was an we told you that it's the acceleration, then that would give you another mark.
Okay.
So he is right. We won't give you 2 marks for saying the same thing. All right, but now the calculator work gives you 1 mark.
Now, isn't we already 8 there?
That is 8. That's the final. They want they want this V. So if we do the maths, we're going to say 0.4. We're going to do this first, times by 5. Then we're going to minus 8. Who did this on? Guys, you should all have your calculators out. Everyone, have you got done it? What did you get? 2. On the dot. Did you all get 2? It's a bit weird
I don't
with
think that's how it
the
works.
scale.
Oh, the answer is 6, man.
It's 6, yeah. So that's 2 plus 8.
Did you just forget to add the 6? Thank you.
Not good enough, eh? Not good enough.
6 meters per second. Always go and write the right unit. And then you go back to your question and they say, calculate the value of V. So do we have to care about direction? It says the value of. But if it just says, what is the velocity? What would you have had to add? What would it be? In the direction of motion means nothing to me. What would you say?
North.
North. Guys, if the question says north and you say in the direction of motion, sorry, no marks. I will still mark it wrong. The memo is not always right. No, if the question tells you north, in which direction of motion? Because here it's going south. So you can't say in the direction of motion. Where? Then you have to say in the original direction of motion, or you have to say in the direction of motion that was traveling at 5 seconds. You can't just say in the direction of motion.
Isn't 8 VR?
Yes, but that's not what the question asked for.
Oh,
They asked for the value.
oh, I thought 8 was
They're
VR.
asking us for that value there.
Oh, I thought 8 was VR.
8 is VI.
I thought 8 was VR.
That is VI. Okay, but you've got it now. All right, then. During which intervals is the resultant force on the cyclist 0? Now you did, you would not get a question like this in next week's test because it's on Newton, but you actually did it in Form 2, where we said if the acceleration is 0, then there's no resultant force because the object is stationary or moving at a constant velocity. Can you remember that from Form 2? But that's why we won't ask you now. So it will be everywhere where the line is flat. So it will be in that part there and that part there. But we will not ask you this in the test. Because it's Newton. We haven't done that yet. You did it last year, but it's not in your test. It's not in your chapter. Everything that's in your book's chapter, you need to be able to do. Without using equations of motion, determine the displacement of the cyclist after 15 seconds. So you're not allowed to use those equations of motion. The question tells you without using them. So we need to use our graph. If they want the displacement, luckily when we started this question, what did we tell ourselves about the displacement.
Area.
Great. The area is the displacement. So because we did that in the beginning already, we already, if you are working out things along the way that's not in your diagram, put the values in so that when you get to a later question, you don't forget that you've actually worked it out already. Now we can say we want to get the displacement. So for question 3.3, we can say displacement equals area. Why will I go through all that effort? Why?
To mark for writing down the
Just for saying that, or you can say area, then look at it. Is it a triangle? Is it a rectangle? So for 3.3, they want after 15 seconds. Now, this word, we've realized, causes drama in this little group that we have here. Who thinks that that means after 15 seconds this way? Hands up. Don't be shy. If that's what you're thinking, that's what you're thinking. Okay, because it says after 15 seconds, so that means beyond 15 seconds. Who thinks that? See, now I've just convinced you that it's after 15 seconds. That just shows you with a little bit of word twisting. Who of you thought that they say, when they say displacement after 15 seconds, that they mean this part?
Because after 15 seconds, that's after 15
Okay,
seconds, my brother.
but don't argue about it. Zenande, what I'm trying to show you is that words are sometimes confusing because I can see validity in both. The first question, when you're looking at the blue, it's what is the displacement after 15 seconds have passed? If you're looking at the black arrow, it is after 15 beyond 15 seconds. So both can be right. It depends how you see the English. So they don't do that anymore, or we shouldn't do that anymore. The question should say, what is the displacement between? And then there will be an A and a B. Or they will say between 0, stop arguing about it now, between 0 and 15 seconds. Then it's clear. Am I right? Then everyone knows what we're talking about. So when you're confused about something like that in a test, please put your hand up and ask. Because if we're not allowed to answer, we'll just say, sorry, we can't tell you the answer. But if it's something like that, that's an ambiguous wording, please put your hand up, we can fix it. Okay, so, and then we know not to use the wording again. So this has happened in matric finals, where they then had to accept both, because the words are bad. All right, so let's see. If we assume, I think, and that's what the examiners in the past have meant by it, is that it is for that little time there, before 15 seconds. So if it's okay, both are right. If they say that, if we say area, now you need to decide, what shape have I got? And that's not a very easy shape to deal with. But what we do, and you are allowed to do this in your exam, that block there, I can get the area of easily. Sorry, my lines are very bad there. I can easily get the area of that block. Oh, it's nice to try and write with an eraser. Very clever. That block there, I can get the area of. So you are allowed to do that and say, in your answer, you can say that is going to be equal to, and then you show it's a block. Can you all see the yellow? And then the other area is that little triangle. So we're going to say it's a block plus a triangle. We give marks for that. So if you didn't say delta x is area, but you said delta x is block plus triangle, that's the same thing. You are telling me that you know it's the area, and I'll give you a mark for that. It's fine. So please Remember, plain and simple is always the best way to go. Then we're going to say, fine, this is a block. How do I get the area of a block? You don't have to put this step in. How do I get the area of a triangle?
Half times base times height.
Half base times height. Now length times breadth, we can see it's 6 times 15. Please use brackets, guys, because your calculator does BODMAS. Put brackets, 6 times 15, and then this is half. Base is 15 times height is 6. You put that all in your calculator and you get me a beautiful answer. Yes. Oh, absolutely. Why is it not 6? Guys, I am blonde.
No, the base is 15.
The base is not 15. Guys, we're here.
Oh no, my
It's
fault.
this thingy here. It's 5. That's the base. Okay, so it's half C. What exam stress or crowd stress does to a brain. 5 times, what is the height? 2. Now the rest is your calculator's job. Give me a beautiful answer. 95 what? 95 centimeters. Guys, what am I working out? So what's the unit? But, guys, that's not the end. Because now we need to go and see, is the question asking me for a vector, or is the question asking me for a scalar? They say, determine the displacement. So we need direction. It is still going in the positive direction. So what is my... Because it's still sitting above the line. Does this make sense? Okay. Now, the next question. Are there some of you that there's a lot of motion? Are you needing to go? Are you still fine? Okay, then the next question. Guys, no. So we now know that this is 95 meters. Remember what I said? Once you've worked something out, put it in your diagram so that you don't later on go and work it out again and waste your time. We see so often that people work something out, or the question tells you something, and then you go and work it out again. Please don't do that to yourself. Do not waste time on working things out again. So we've done 3.3. So for 3.4 there, yeah.
The cycle is going down.
Yes. Oh, that is a very important question. Please remember, oh, no, not yet. If you're looking here, it's going from 8 to 6. Did he slow down there? Yes. But here the velocity stays 6, stays 6, stays 6, stays 6. So what can you tell me about his velocity in that bit? Constant velocity. Acceleration is 0, yes.
And then you slow down again and it goes down.
Yes. Then, guys, then he goes slower, 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 slower until, what is his velocity here? So what does he do when the velocity? He stops. So he slows down, and at this point, whenever you're at the x-axis on a velocity time graph, you have stopped. So he has stopped. Then, what is he doing here? Now he's actually speeding up until he goes backwards at 9 meters per second. Because remember, the one thing I said to my class as well is, can you go slower than standing? Can I go slower than what I'm going right now? Okay, you cannot go slower than standing still. So whenever you are going away from your x-axis, if it's a velocity time graph, you are speeding up north. When you're going this way, you are speeding up, but you're speeding up south. So further from 0 is always speeding up. Closer to 0 is always slowing down. There's always a question on that. In multiple choice or longer questions, but there's always one like that. The Form 5 test is always also on the same day as yours, I see now.
No.
But why does it affect you? Just affects me because I have to set it. Okay, moving on. Then, guys, the question 3.4 says, calculate the acceleration of the cyclist between 15 and 25. So go and find that on your graph. Tell yourself where you are, between 15 and 25. You are allowed to use highlighters. So for question 3.4, I'm between 15 and 25 seconds. But if they're asking me for the acceleration, what is the first free mark I'm going to earn? Thank you. Acceleration is equal to gradient. Or acceleration is equal to change in y over change in x. Then you go and look, where are my 2 points? This is my last point. So it's going to be minus 9 minus, that's my first point, 6. If you're getting confused with your points, label them. This is point number 1, point number 2, point number 1. Because it's y2 minus y1. Then it is x2, which is 25, minus x1, which is 15. So this gives me 15 minus 15 over, too much talking with me, minus 15 over 10 gives me minus 1,5 meters per second squared. But you do not get full marks because you've got a negative answer there that for a random person reading your answer means nothing. You need to write it in plain, simple English. Yes.
1.5 meters per second squared sound.
Yes. So you're going to go back to your question and see if the word magnitude is there, then you don't have to worry about direction, but it's not there. It says calculate the acceleration. So we're going to say therefore, always go back and answer the question. Therefore, acceleration is equal to 1,5 meter per second squared. You write it as a positive and you interpret what that sign meant. So that sign meant that it is accelerating sound.
Now what I noticed is that in the start it said the graph between T0 and T5 is the gradient is 0.5, so you can change at different times the gradient.
Guys, another important question. Listen. Anywhere on this line, what will the gradient be?
1.5.
It's a straight line, so it doesn't matter where on that straight line I get
Well, I
the
mean, it
gradient.
says 3.1. 3.1 it says the graph between, I'm saying like ma'am, it can change depending on...
Yeah, so that was a different motion. This is a different motion. So it can change, but for that part, it will be constant.
Okay.
So now, that 1.2 is 0.4 sound.
That. Guys, listen again. Let's just quickly finish the last ones. I know we're out of time, but let's just listen. Determine the time at which the cyclist starts to move south. We answered that question in the first 3 seconds. When does he start to move south? Yes, there. Because he slows down, stops, speeds up, and there he goes. Guys, 0 time, 0 velocity. So the question actually says determine the time. So they want a specific time. I would just say, we know that acceleration is constant. So if there's 5 seconds this way and 5 seconds that way, what is that? It must be 20. Because it's a constant acceleration. The middle between 15, am I right? Yeah. Middle between 15 and 25 is 20. But you could calculate it as well. Guys, you can calculate it because you can say, you know that the gradient there's always a few ways in science to do things. You can say change in y over change in x. We've just worked that out, is minus 1,5, right? Then you use another piece. You're using this piece here. So then we say for that piece, change in, so it's 0 minus 6. Yeah, for the y. But on x, we don't know what this time is. You can just call it x. So here it's going to be x minus 15. It's that bit there. Now you do the algebra, and you're going to see that x is equal to 20 seconds. I hope. Calculate it. Do the algebra. So you're going to say minus 1,5
times 15.
divide by minus 6. Invert it and plus 15. Do you get 20?
I'm getting
19. Really? Is it not 20?
Unlucky.
For time, man, you said x minus 15.
Oh, you're absolutely right. Why am I wrong with my 20? Guys, I should have used a bit more logic. I told you I'm very blunt today. We worked this out to be 6. So that bit there went to 6. This bit here went to 9. So are they equal? There's a bit of a blobs in this graph, but the answer is not 20, it's 19. We will make sure that it works out.
Man, so why would you say x underneath 0 minus 6? Why would you say x minus 6? If
Yeah.
the space is small. For time, man, for time, yes.
Because we don't know what that is.
So then you say,
You can call it anything you want. I just made it an unknown.
no, I'm talking about the minus 15. That's what I understand. I'm talking about why do you put the minus 15? Because x
Because it's this value, whatever it is, minus 15 is my delta x. Final minus initial. Guys, listen, one last thing. Okay, remember, change in y over change in x is y2 minus y1. So that was 0 minus 6. Are you happy with that part? And change in x is x2 minus x1. But I don't know what this x2 is. You can write x2 there if you want. x2 minus x1. x1 we know is 15. So this is delta y and this is delta x. And then we just solve for x because we know that this value is minus 1.5 because we've just worked it out. Does that make sense?